Now we finally want to turn our attention to using truth tables to determine validity or invalidity of arguments. To do that, we're going to rely on the definition of validity. An argument is valid if and only if, whenever the premises are true, the conclusion has to be true. So we'll fill out our truth table for each of the premises in the conclusion. We'll look at the rows where the conclusion is false and see if there are any rows where the conclusion is false and the premises are true, because that means there's a way for the premises to be true without guaranteeing the conclusion is false. So we violate that definition of validity. So we're looking to see whether or not the argument violates that definition of validity. If there's a row where the premises are true, conclusion is false, it violates the definition of validity, it's an invalid argument. If there's no row like that, no row where all the premises are true and the conclusion is false, then it doesn't violate the definition of validity and it's a valid argument. Let's look at a couple of examples. So here we have modus ponens. P, if P then Q, conclusion Q. So we fill in our guide columns in the body of the truth table. We have that horseshoe connective, we fill that in. And now we look at the two rows where the conclusion is false. Q is our conclusion, so here's a row and here's a row. And we look at the main connective for our horseshoe. So in this row, it's false. P, the other premise is true. They're not both true, so it doesn't violate the definition of validity. We look at this row. P is false, so even though our horseshoe is true, it doesn't violate the definition of validity. There is no row where the premises are all true and the conclusion is false. It doesn't violate the definition of validity, and so it is a valid argument. Let's look at another one that does violate that definition. This is affirming the antecedent. So we say, okay, look, Q, if P then Q, therefore P. Fill in those values from the guide columns in the body of our table. Fill out our conditional statement column. Now we look at the two rows where our conclusion, in this case P, is false. In this row, the conditional statement is true, but Q is false, so they're not both true. It's fine, doesn't violate the definition. In this row, however, both the conditional statement and Q are true. So both our premises are true, our conclusion is false. It's possible for the premises to be true without guaranteeing the conclusion is true. It violates the definition of validity, so it is an invalid argument. Let's go through some other examples. Suppose we have the following argument. We put it on our truth table here, copy the truth values from our guide columns onto the body of the truth table. Now we've got three connectives. We want to do our tildes first. This is something we haven't seen before. We've got two tildes here. So this tilde negates P, and this tilde negates the negation of P. So we start here, and then we go here. So there's our tilde P. There's our tilde P. Now we've got our truth value for tilde P here. That's here. We've got our truth value for Q. Those are our two disjuncts, so we use the rule for the wedge. Only way for the wedge to be false is if they're both false, and that'll give us this. Now, again, we look at the two rows where our conclusion, in this case Q, is false. Here's a row, and here's a row. In this row, our premise here is false, and our premise here is false, so they're not both true. Perfectly fine, doesn't violate our definition. In this row, where our conclusion is false, P, that's one premise, that's true, and then our disjunction is also true. Both premises are true. The conclusion is false. Therefore, it's possible for the premises to be true without guaranteeing the conclusion is true. And remember, this is the truth value for our formula for this premise, right? Under the main connective, the last connective that we do. So this argument is invalid, violates the definition of validity. Here's another problem. Put it out on our truth table. Copy the truth values for our guide columns in. Do our tildes. Do our conditional statements. Now we look at the two rows where our conclusion, tilde P, is false. We're looking under that tilde here. Here are our two rows. Row 1, conditional is true, tilde R is false. Row 2, conditional is false, tilde R is true. So there are no rows where the conclusion is false and both of the premises are true. So this argument is valid. Let's try another one. And again, try to do these, then see how I did it, see if you got the same answer I did. So we write out our simple statements, our formulas, our guide columns. We copy the truth values from our guide columns in. Now we're going to start with our dot, that connective inside the brackets. Only true when they're both true. We go outside, tilde, tilde of the truth value of this whole thing. That gives us that. Then we go to our next one. We start with our tilde. Then we do our horseshoe. Now we look at the two rows where our conclusion, T horseshoe tilde Z, is false. That's here. Sorry, there's just one row. And we look at our premise, and the truth value for our premise here is right here. And this last connective, the main connective. And so this is a valid argument. Here's another one. Again, see if you can do it. Then watch the video. See if you get the same answer that I got. We put out our premises and conclusion on our truth table. Fill out our guide columns. Transfer the truth values from our guide columns onto the body of the truth table. Now we'll start off doing our tilde first on that first premise. Then we'll do our biconditional, a triple bar there. Then we'll do the truth value for our tilde inside our second premise, parentheses. Then the dot. Then we'll do the tilde outside. Then we'll do the horseshoe for our conclusion. We've got one row where our conclusion is false. We look at our two premises under our main connective. Here's our main connective here. That premise is true. Here's our main connective here. That premise is true. Both our premises are true. Our conclusion is false. Our argument is invalid.